Hello class, this is Ms. Martins, and today's objective is students will be able to classify a compound as an electrolyte or non-electrolyte using table F, K, and L. So basically, we're going to have an understanding of what an electrolyte is, and we're going to use table F, K, and L in order to determine if a compound is an electrolyte or not. First, we're going to start out with a definition. According to the Merriam-Webster dictionary, an electrolyte is a substance that, when dissolved in a suitable solvent or when fused, becomes an ionic conductor. What does this even mean? An electrolyte is a compound that will dissolve in water to form a solution that will conduct electricity due to the presence of ions. We know that ionic compounds conduct electricity in the liquid phase, therefore they are electrolytes. An electrolyte is a compound that will dissolve, so it has to be a soluble substance. If a substance is insoluble, it is not an electrolyte. However, if a substance does dissolve in water to form a solution but does not conduct electricity, it is called a non-electrolyte. Examples of non-electrolytes are covalent compounds like sugar and alcohol. So just to refresh using table F, remember one of the key components of a substance being an electrolyte is if it's soluble in water. Table F gives us a variety of ions, and they allow us to determine whether they're soluble in water when combined with another ion, so forth and so on. Remember, this first row here tells us ions that are soluble, that form soluble compounds, and these are the exceptions. This tells of ions that are insoluble compounds, and these are its exceptions. So solubility is one of the main components of determining whether a substance is an electrolyte or not, and we can use table F to determine that. To determine that. Polarity is going to be another criteria for determining whether electrolytes are what electrolytes are. So polarity, remember, like dissolves like. This is just a review from chemical bonding unit. For something to be polar, for a substance to be polar, a compound to be polar, there needs to be some sort of uneven distribution. So here we have HCl. You can see that hydrogen has a partial positive charge, where chlorine has a partial minus charge due to the huge electronegativity difference, and this creates a polar substance with an uneven share of electrons. So electrolytes, once again, polar substances dissolve in water because water is polar. So we're going to be looking at solubility and polarity, and when a substance dissolves in water, that means it's polar and it has a distribution of charge. Ionization comes into play when we're speaking of charge. What word is present in ionization? The word ion. An ion is formed when an atom either loses electrons or gains electrons. And when this occurs, we have a charge. And this charge is very essential when looking at electrolytes. There is a dissociation of compounds into ions once it is dissolved into water. And this is one of the key components of identifying an electrolyte. Dissociation means breaking apart the molecules, the bonds of molecules. So dissociation occurs when a compound is dissolved in water and the compound technically breaks apart into ions. The molecules that can do this are salts, which are ionic compounds. An ionic compound consists of a metal and a nonmetal. And other forms of compounds that can dissociate are acids and bases. So our electrolytes are going to be ionic compounds, which are in the aqueous form, and acids and bases. This is very essential to understand, to distinguish between electrolytes and non-electrolytes. So once again, an acid dissociates into H plus and Cl minus. Bases are known as electrolytes because they dissociate as well when dissolved in water, and most importantly, salts in the aqueous solution. So which substance here is an electrolyte? First, I'm going to look at CCl4. CCl4 is carbon is a nonmetal, chlorine is a nonmetal. This is a covalent compound, so I would not classify this as an electrolyte. Same here, carbon is a nonmetal, hydrogen is a nonmetal. I would not classify this as an electrolyte. HCl is also a nonmetal, two nonmetals. This is also a covalent compound. However, this one is different, and we'll take a look at this soon. And H2O is also a covalent compound. So we cannot use the distinguish between covalent compounds and ionic compounds to answer this question. We have to look at whether any of these choices are acids or bases. So if you look at table K, we can see that HCl is in fact an acid. So that is going to be our answer. HCl is an acid. It's going to dissociate into H plus and Cl minus when dissolved in water. Therefore, that substance is an electrolyte. So for our next question, which substance is a non-electrolyte? So we know that our non-electrolytes, they can't be acids or bases, and it won't be an ionic compound. So we're going to be looking for a covalent compound most likely. KOH is actually a base. HNO3 is an acid. CaCl2 is an ionic compound. And then C6H12O6 is going to be our covalent compound, hence our answer. So once again, KOH is potassium hydroxide. That is found on table L. This is a base. HNO3 is an acid. That is going to dissociate. CaCl2, calcium is in group 2. Cl is in group 17. That is an ionic compound. It consists of a metal and a nonmetal. And number 4, C6H12O6, that is a covalent compound. It is a sugar. It does dissolve in water. However, it will not create any charges. So that is a non-electrolyte. So we're going to go through a few examples of compounds, and you're going to try to determine whether they're electrolytes or not. Remember what electrolytes are, and when you're doing this, electrolytes are ionic compounds, acids, and bases. But remember, the ionic compound has to be in the aqueous form. Number 2, remember what they aren't. They aren't covalent compounds. Covalent compounds may be able to dissolve in water. However, they do not form a light. Like, they're not going to dissociate. So therefore, they are not electrolytes. And be sure to understand any mistakes and use the prior slides to understand. So if you're confused with anything that I go over, you can refer back, watch the video again, and try it over until you get it. So the first example is NaOH. We're going to look at table L, our common bases. NaOH is a base. It's called sodium hydroxide. Therefore, this is an electrolyte. It will dissociate in water. NH4Cl. So this is a tricky one. However, if you look at table E, NH4 is a polyatomic and Cl is a nonmetal. So therefore, this is an ionic compound. This is an electrolyte. KCl, we have another ionic compound here. Potassium is in group 1. And chlorine is in group 7. Potassium is a metal. Cl is a nonmetal. This is in the aqueous form. Therefore, this is an electrolyte. It will dissociate when in water. CCl4, this is a covalent compound. Carbon and Cl are both nonmetals, and this is not an acid or a base, so this is not going to be an electrolyte. CH3COOH in the aqueous form. So this is kind of a tricky one, because these are all nonmetals, so you would assume that it's a covalent compound. However, if you check table K, our common acids list, this is ethanoic acid. Remember, acids and bases are considered electrolytes because they will dissolve in water, dissociate in water into ions, so this is an electrolyte. Our next example, NaCl. This is a tricky one. It's in the solid format. Yes, this is an ionic compound, but it's in the solid form, so this will not be an electrolyte. Remember from earlier, ionic compounds conduct electricity in the liquid phase. So those are electrolytes. This was in the solid phase, so it's not an electrolyte. However, NaClAq is an electrolyte because it is in the liquid phase. It's a solution. Our challenge question, CH3OH. So this does look like acetic acid. However, it's not. This is an alcohol. This is a covalent compound. So this is not an electrolyte. This is not acetic acid. There is an extra carbon and oxygen missing for this to be acetic acid. So this is not an electrolyte. Be careful with questions like that. C6H12O6, this is actually glucose. This is a sugar. This is a covalent compound. Carbon, hydrogen, and oxygen are all nonmetals, so this is not an electrolyte. We have H2SO4. This is on table K. It is this is sulfuric acid, hydrosulfuric acid. This is an electrolyte. For your exit ticket, complete the Google form entitled Initial Activity Refresher on table F. That should have been done before you watched this PowerPoint, but you can still do it. Refresh yourself on understanding the difference between soluble and insoluble compounds, and then complete the electrolyte practice questions to see if you understand this video. And if that practice question is a little too difficult for you, I recommend writing questions in the Google Classroom or watching this video as many times as you need. If you have any questions, email me or write in the comments of the Google Classroom. Thank you for listening to this lesson, and make sure that you enjoy your day.